Our next speaker is Amr Awadallah. Amr is the co-founder and CTO of Cloudera. This is the largest Hadoop distribution. Prior to Cloudera, he had spent time as entrepreneur in residence at Excel Partners, and before that, he was actually VP of Product Intelligence at Yahoo. One interesting thing I wanted to share with you about Amr is that he's an avid gamer. His favorite game of all time is Halo, and his online handle is Master Chief. It's game on tonight if anyone wants to challenge him on Halo. So please welcome Amr.
Yes, I need the mic. Yeah. Okay. Will you give me a 15-minute warning and then a 10-minute warning? Did you switch this? No, it's okay. I'll just come here and yeah. Can we connect the projector? Okay. Okay. This is to wake you up? So, great, thank you. So I have a couple of questions first, just to calibrate the audience in the room, which helps me with the speed of which the audio on. Oh, is the mic on? Can you guys hear me fine? Yeah, that's better. So first question is, how many of you heard about big data before? Please raise your hand if you heard about big data. Okay, I'm in the right room. Good. Next one, hopefully also we'll get a large number of hands for this one. How many of you heard about Hadoop before? So almost 100% of the room. That's great. So next one, trying to segment the audience in the room. How many of you are academia, professors, students, in that category? So if you can please raise your hand and wait for a second. So let's say about 40%. How many of you are in the industry but on the technical side? Okay, that's about 30%. How many of you industry but business side? And that's about maybe 5%. That leaves about 15% undefined, because you should fall in one of these categories. And then my last question is, how many of you heard about Cloudera before? If you can raise your hand, please. Okay, so it's almost 80%, if I captured that correctly. So that will allow me to skip on this next slide very, very quickly. But before I go to the next slide, so my name is Amr. I'm one of the founders of Cloudera. I've been there since inception, which is 7 years now. And before that, I was at Yahoo for about 8 years, where I had the pleasure to work with Osama, with Basil, with Rajesh, and a number of other people. A lot of ex-Yahoos at this conference. So this is a brief snapshot of Cloudera. I'm not going to bore you with all the numbers here. I'll jump straight ahead to the mission. The mission of Cloudera, besides being known as the largest Hadoop distribution company, our mission really is about helping organizations leverage all of their data, where all here is a very important keyword. All here means any type of data. Structured data, meaning transactions. Semi-structured data, meaning logs, logs, XML, JSON files. Or unstructured data, meaning emails, tweets, images, videos, stuff like that. So how you can combine all of that and then ask bigger questions, which means go beyond SQL. And I'll explain that in a second. So first, motivational slide. We at Cloudera believe strongly that there is a data revolution going on. And this data revolution will be equal to, if not bigger than, the Industrial Revolution. So as you know, during the Industrial Revolution, we shifted a lot of the manufacturing from building stuff by hands to building stuff by machines. Companies that were able to embrace that shift survived and did very well. Companies that did not went away. Countries that embraced the shifts became the leaders of this new economy that we're in today. And we think a very, very similar shift is happening today. We are at an inflection point, very similar to that, with how we use and how we leverage the power of data. Why is this happening today? Three things, three very important trends. The first one is instrumentation. Is only today are we more capable and more sophisticated than ever in terms of collecting information, not just in the virtual world, meaning inside of our computers and servers, but also in the physical world. So to give you a very simple example of that, 10 years ago when you went to take out money of an ATM, from an ATM machine, the only thing that we captured 10 years ago was the transaction. Person X, at time T, took out Y dollars from account Z. Today, we still capture that, but in addition, if you have the mobile app for the bank on your phone, we're capturing that you're standing there right in front of the ATM machine. The ATM machine most likely is taking a picture of your face. The ATM machine is capturing how you're moving your finger on the touch screen of that ATM machine. So a lot of the activity that's happening in the physical world is being captured. That is happening across all industries. In agriculture, we have sensors that measure irrigation, measure temperature, measure humidity, etc., the rate of growth of the crops, etc., etc. In transportation, we have RFID tags on everything. So that's the number one reason for why this whole big data thing is happening, is that we are more capable than ever at instrumenting and measuring stuff. Number two, which is a very important trend started by companies like Google and Amazon, is the shift in how we do work across our organizations and enterprises to what we refer to as the segment of one. Segment of one. And that's because of the long tail effects that many of you are very, very aware of. Historically, when we tried to target offers to our customers or detect fraud, we used to cluster people into segments, right? So we'll come up with 20 segments, married with children, low income, high income, lives here, lives there. And then we'd do our targeting and our offers based on one of these segments. And as many of you know, that led to a lot of false positives and a lot of false negatives. Because it's very hard, because of the long tail effects, to characterize everybody, the millions of users that companies and organizations have, into 20 or 30 or even 1,000 segments. So there is a big shift across industries towards the segment of one, building a profile for every single user. So I'll give you a personal example of how I benefited from this segment of one thing. I happen to be from the Middle East. I'm from Egypt. And 4 years ago, 5 years ago, whenever I would travel, every time I would get randomly selected for screening. And the reason why I'm being randomly selected is because I fall in that segment that is supposed to be a high suspect segment. Even though it's a huge segment, there is millions of people in it, I would still get picked because that was the only way that we would do things. Roll forward to today, and for every single person, a profile being built, a risk profile of their aptitude to do something bad or not. And luckily today I never get stopped, so hopefully that says something good about me. But it's benefiting us in many, many ways. It's benefiting us with the offers we get when we're browsing online. It's benefiting us in medicine and how doctors are going to be prescribing medications for us. It's benefiting us in terms of how insurance companies will price the policies they give to us. Because if I'm driving well, I will get a better price, as opposed to just because this is my income and this is my education, I will get a better price. So segment of one, very key. And the last but not least is just the industry. Hadoop and Spark and all the technologies that are happening are enabling us to do advanced analytics that we just couldn't do before easily at scale on multi-type data. So these three trends combined are what are leading to this. And obviously what they require, as many of you already know, is having a system, a platform that's able to absorb any type of data, whether that be transaction data, clickstream data, social data, sensor data, etc., 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 and then leverage that data in many different ways. Historically, the only way we would leverage data is through SQL. right? And many of us, many of the banks we work with, the telecommunication companies, the governments we work with are realizing that SQL can't do everything. We know this in computer science. We know this. We know that SQL is not a Turing-complete language. You cannot express every algorithm in SQL. You just can't. Yet, we have been using it that way and thinking it is the answer to all the problems. Today, it's becoming very clear that we need to go beyond that. And that's the other key requirement of this new platform and new ecosystem that we need to be working on. All of you know this. Structured data is the type of data that you find in Oracle, SAP, and so on. Very well-defined transactions. First name, last name, address, amount. And then unstructured data is everything else. And it's growing by leaps and bounds. This is a real problem. And companies are waking up to it every day and seeing how quickly that data is growing and seeing how much they're leaving on the table because of not leveraging that data. This brings me up to my next question, which is, how many of you know what is this picture of? I'm trying to wake up people, so if you know, please raise your hand. Only saying 10%, go up. This is Hadoop. This is the original Hadoop, by the way. So this here is Doug Cutting, the creator of Hadoop. This is myself behind him, not very important. Doug, sorry if you guys heard the story before, but Doug was trying to come up with a name for the platform. This is more than 10 years ago. And this was his son's toy. His son was 3 years old, and he had this funny-looking elephant. The Hadoop logo looks much nicer than this now. And out of the blue, one day, his son literally made up the word Hadoop. The 3-year-old made up that word. And Doug liked it, and he used it for the project. His son today is 14 years old, and he's very proud of his contribution to the data industry. I'm not going to bore you with the power of Hadoop. From the technology side, you all know the details, right? Divide and conquer, extremely scalable, extremely agile, works with any data type, and allows you to have multiple processing engines running on top of that data. And one of the key benefits that I'm sure you heard many, many times is just the cost advantage that it brings. That said, coupled with this technology story, there is a very important business story that Google, Facebook, and many of the new generation companies try to teach everybody else, is the old way that we were doing things for how we model our users and how we build applications for them in our organizations is flawed. So the old way is every time we have a new application within our organization, we make a new copy of our data for that application. For example, in a bank, we'd have a copy of the customer data for the mortgage stuff, for the checking stuff, for the credit cards, for the loans, et cetera, et cetera, et cetera. Even though it's the same person in every one of them, we'd make a separate copy. The trend that, again, Google advocated and many companies now are following is the trend of Customer 360 or Know Your Customer. These are the acronyms that you would frequently hear. And it's about creating one repository with all of the data about our customers. And instead of copying the data to the application, we want to be able to copy the applications to the data. That journey will take some time, but that's the end point that we're all trying to work towards. We're trying to work to a point where we can capture all of that data once and have the applications move to the data instead of the other way around. That is what will enable governments, organizations, and enterprises to be more agile than ever in terms of how they leverage data. Proof point to prove that is you and your personal use of the smartphone. So I would frequently ask you, my audience in general, how many, over the last 5 years, how many of you shifted almost 90% of your photo-taking behavior to be with your smartphone instead of a camera? Please raise your hand. Almost the entire room is raising their hand. Some of us don't use a camera anymore. I still, by the way, but some of us don't use a camera anymore. And not only did we shift our behavior to the smartphone, we're consuming more. We're consuming more. We're using it more. We're taking more photos than we ever used to before. Why is that? I want to hear some answers. Convenience of what? Say again? Availability of what? Yes, so the key word I'm looking for, I was waiting for somebody to say it.
Using a chair.
Thank you. It's the convenience, The answer I usually get first, by the way, is people would say the convenience of size is small in my pocket. We had compact cameras that were small in our pocket. They're dead. Nobody uses a compact camera anymore. You use the DSLR cameras, but not compact cameras. The second answer I will always get is the convenience of sharing. The power of the smartphone, the reason why we are consuming way more than before, is the agility of once I capture that picture, once I take that picture, the data is immediately available to my email, to my calendar, to my Facebook right away. Versus I have to take out that flash card and go stick that flash card in a desktop or put a cable, copy over the data to the application, Photoshop or whatever, and then start working with it. So our agility came from the immediacy of once I capture that data, I'm able to consume it in different ways. And that's exactly what we're trying to do for the enterprise. So if there's one thing that I would like you to remember from this talk today, is in many ways what we're trying to do is to create the smartphone of big data. It's not going to be a small smartphone, by the way. It's going to be a cluster with many, many servers. But the end goal is the same. This is typically the journey that our customers go through. The journey has two sides. The left side is not about doing anything new. The left side, where most people start, is about saving money. It's about doing the ETL and the batch jobs much quicker. And it's about offloading some of the work happening in data warehouses and mainframes to run inside of Hadoop instead because of the economics. So the left side is really just about operational efficiency. It's about doing things faster, bigger, and cheaper. And the reason why people start here is because it's easier to start learning the system and working with it and to retrain the IT talent to consume this new powerful technology. Once they get comfortable with it, and once they have sufficient data inside of it, then they start moving to the right side, which is the true power of the Hadoop. The true power is not scale and cost. The true power is agility. It's being able to do what we refer to as schema on read versus schema on write, evolve our data models at much higher speeds than ever before. Be able to store structured data side by side with semi-structured data, side by side with unstructured data. And then from then you move on to the next step, which is NoSQL. First show of hands, how many of you heard about the term NoSQL? I hate the term. I hate it. Because SQL is so important. I can't stress to you how important SQL is. In terms of number of developers that know how to speak SQL, in terms of number of deployed applications that are already speaking SQL, and in terms of the ecosystem of tools that work with SQL. Instead, at Cloudera, we like to rewrite NoSQL as not only SQL, as opposed to no SQL. Right? The idea there is I still want to be able to do SQL, but if I'm doing a complex semantic extraction, I want to be able to use a text-based engine or to use a Spark engine. If I'm doing graph mining, then I want to use something like Giraffe to mine the data set that I have, which is more suitable for graph data structures, et cetera, et cetera. So how can I go beyond SQL and be comfortable going beyond SQL is the next step, because we have been, unfortunately, we have been all trained on SQL as the only way for answering all questions. And now we need to dislodge ourselves from that, which is very important. And then last but not least is really Nirvana, which is the kind of the highest level of enlightenment in terms of adopting this platform, which is achieving the picture I showed you earlier of having one copy of the data, having all the customer data, everything we do, one copy, and have the applications move to the data instead of the other way around. That's a multi-year journey. It will take companies many, many years to achieve. But that's the highest level of maturity. Now shifting gears a bit into the Hadoop stack and the Hadoop ecosystem. 2006, so almost 10 years ago now, that's when Hadoop was born. And back then, as you know, it only had two components, the storage system and the MapReduce system. Roll forward, and today, this is describing mostly the Cloudera distribution, but today we have more than 20 different components that we include in this stack. And we predict that over the next few years, we're going to see new components being added every year. And that's the power of this ecosystem. The power of this ecosystem is how the community, as we solve new problems, we come up with better ways to do them. And because of the Yarn architecture, we're able to add these new ways into the ecosystem. one of the key tasks that we have at Cloudera is curating this distribution. So we do a lot of analysis and reviews of the new projects as they come out, how our customers are adopting them, and as they start to adopt them and ask for them, then now we curate them, we make sure they work with all the other projects, and we add them into the stack. So for example, Spark, we added Spark to the distribution about 2 years ago. That's when Spark was added. So actually, the present is not today. Present is 2013. This is Cloudera Enterprise at a very high level. Again, it's about enabling this process of process, discover, model, serve. And the goal, as I said at the beginning of the presentation, is one place for unlimited data of any type. Any type is very, very important. And then overlaid on that, multi-framework data access. Being able to do SQL, but being able to do many, many other things. Now, I'm not going to bore you with this from the marketing team, but this is what makes Cloudera special. It's all this secret sauce here around high performance and open standards and security. Zooming in, if you zoom in, these are the different Hadoop projects I had in the previous bar chart overlaid onto this pipeline. So you can see technologies like Scoom, Flume, and Kafka for ingest. MapReduce, which I believe quickly MapReduce will be replaced by Spark. For Transform, Hive and Pig will both be changed to run on top of Spark. In the discovery area, we have Impala for interactive analytics. We have Solar for doing text search. In the modeling and machine learning area, SAS, as you know now, they support this platform. R, which Microsoft acquired, the Revolution Analytics, supports the platform. Spark now has Spark R and has Spark ML and MLlib. And there's new systems like Oryx, and actually Cloudera just released something very new called IBIS, which I highly recommend many of you to take a look at, IBIS. And then on the serving area, we have HBase, which is low latency, and Spark streaming. So this is kind of all the projects and how they relate to the different stages. Key for this to work, one of the key things and one of the things we spend a lot of time at Cloudera on is how do we make all of these components work together in a unified way. So you have unified security, access control, encryption, unified manageability, and unified governance across all of these components. And these things, typically the research community and the academic community don't look at. How do I make this fit the business processes inside of companies better? Sometimes we consider, in research, we consider these to be a little bit boring, but they're very, very critical and important. So one of the pieces of advice here is I would advise many of the researchers among you to start looking deeper at these issues. This is the architecture that we see evolving inside of organizations. Almost every organization we work with will have this simplified view. One of the key points of this view is that enterprise data warehouse does not go away. You still have an enterprise data warehouse. You still have a Teradata or an Oracle Exadata or an IBM DB2 in your infrastructure. But Hadoop, which we at Cloudera, we call it the enterprise data hub, it becomes the center. All of the input data, structured or unstructured, so you can have structured data from other relational systems or files or logs, they come into the Hadoop enterprise data hub first. You have ETL and batch tools that submit jobs to clean up that data from the original form into the structured data model that you then load inside of your data warehouse, but you still have a copy of in here. This now gives you the best of both worlds in the sense that your most important, most valuable, recent aggregated data is available from the high-performance system of a data warehouse. But your BI tools now have access both to that data and the original data. So if you have an analyst now that is doing a query over just the last month, a simple dashboard, then it will go here. But if they're doing a drill down, meaning they're looking at more granular atomic data, or they're doing a query over multiple years, the BI tool actually automatically will go here instead. That's called multi-source data modeling. And most BI tools now support multi-source data modeling with Hadoop. You are not now only limited to SQL and BI. You can now expand it into machine learning, accessing all of the original data, and doing these converged applications. So this kind of architecture is the blueprint that we see being adopted inside of most organizations. Hadoop doesn't work in a vacuum. Hadoop needs to work with all the technologies that you already had inside of these companies. So in fact, one of the biggest burdens on Cloudera in terms of engineering over the last 7 years was how to make this platform work in a supported way with a very large ecosystem of partners. I'm only putting a few key ones here, but more than 1,800 of them. If we have a given version, I'm going to pick Tableau, for example. If you have a given version of Tableau, then we need to make sure that version of Tableau is certified with this version of Cloudera, such that if the customer calls in to Tableau, they say, yes, we are compatible. Let me find out what the problem is, and vice versa. I can't diminish how hard it is to do that, actually, across such a big ecosystem. It's one of our hardest challenges at Cloudera from an engineering point of view. So with that said, I'm now going to shift into use cases, and then hopefully we'll have time for questions. How are we doing time-wise right now? OK, good. So use cases. I can't even start. I mean, this technology is changing how things are being done across every single industry. When we were starting Cloudera 7 years ago, we actually were turned down by a lot of investors. And these investors told us, oh, you guys come from Yahoo. I come from Yahoo. My co-founders come from Facebook and Google. And they say, oh, you come from there. This technology is only going to be useful for web companies. And we would tell them, no, these headaches, these problems, multi-structural data is happening everywhere. And they wouldn't believe us. Luckily, well, one of them did believe us, and we did get funding back then. Today, we prove them wrong. Like, this technology is being used across every single industry you could think of. In fact, we, the founders, are being surprised by some of the industries that we are helping with. Agriculture is one. Like, I never imagined I would have farmers as customers of our platform. It didn't cross my mind. And that is happening today. So here are some of the common ones, the top examples that we see over and over again. Obviously, telecommunications. One of the biggest sources of data is what's happening inside of these networks. And many, many of our customers in telecom space, like here, for example, in Asia, I can mention Telkomsel in Indonesia and Globe in Manila, but there's many, many others using us for optimizing the network performance. Where do we put towers? How do we change the configuration on the cell phone towers? How do we reduce call drop rates, et cetera, et cetera. Financial services, money laundering is very, very common. Fraud, which I'll talk about in a second. Public sectors, the Australian government is a customer of Cloudera. The common use cases there are cybersecurity and tax. So tax collections is one of the very common use cases. Lots of unstructured data around tax use cases. Retail, everybody wants to do the segment of one, like Amazon. Everyone wants to be, when you buy something, the retailer wants to tell you these are things you're going to find useful next, based on your segment of one, based on your interests and what you bought in the past and what you clicked on. And then healthcare, which my belief is healthcare is going to be changed significantly in the future towards segment of one, where doctors will be able to prescribe a medicine built for us, not just a medicine on the list of medicines they can access. No, a medicine that was be built for us, for our genome and for the disease that we suffer from. These are some of the common use cases across industries in marketing, sales, operations. You guys, I'm sure, saw all of this. These use cases are nice. I love them. They help companies make more money and sell more products. But they don't get me excited as use cases in health that save lives. Right? So definitely the platform helps a lot with all of these use cases. So very quickly, some of our customers and how they use the platform. MasterCard. With them, we achieved actually one of the very first Hadoop clusters that are what's called PCI compliant. PCI compliance is the payment card industry. They have a specific set of regulations you need to meet to be able to keep credit card numbers inside of a data system. We achieved that with MasterCard. They use us for fraud detection. But then they now built a solution. MasterCard has a consulting arm called MasterCard Advisors that they're selling to many retailers across the world. eHarmony, can I get a show of hands? How many of you heard about eHarmony? Don't be shy. I'm not saying you used eHarmony, just heard about them. Okay, about maybe 60% of the room. So for the remaining audience, eHarmony is one of the largest websites in the US for helping people get married. That's the goal. And actually, they pride themselves that they achieve the highest success rates of actually not just getting people to get married, but to stay married for a long time. I like to use them as an example because it's not big data. If you look at the amount of data that they have, it's about a couple of terabytes, just 2 terabytes. It's not that much data. But the algorithm that they run that does the n-squared matching problem across all of the users on their system is a very complex algorithm. And they need to keep running that algorithm. Every time somebody changes their profile, changes their color eyes from brown to blue, they need to rerun all of these algorithms again and again and again. So they need the scalability of the Hadoop system. So the key point of this is big data is not just about data size being big. It could also be about the algorithm complexity being big. Cerner, another very key use case, one of the ones I'm proud of, because not only does it make money, it actually saves lives. They use our platform to predict what's called sepsis. Sepsis is when, after an operation, infection happens and it's starting to grow in your system. And the hospital does not recognize that, and they release you from the hospital, but then you come back to the emergency room a couple of days later with very high fever and very big problems. And now they're able to actually detect that, predict that, and have the patient stay longer until the sepsis condition is over. Manufacturing. This is one of the surprising use cases for us, but now it's happening across the world, where all of the machines in these factories are being instrumented to send back data about their operations. And our customers are using that data to predict whether a machine is going to fail before it fails. So, and that has one of two effects. Either it would save them money or save them time. So historically, what companies would do is that they will maintain the machines every 3 months. Even though they might not need maintenance, they will still go maintain them because they don't want them to fail. And that's just extra cost. Or they would wait until the machine fails, but then now you're going to have a significant downtime, which is revenue loss. By doing this, they're able to catch the failure before it takes place at the right time. O-Power is another very nice example, and this is an Internet of Things example. So O-Power is one of the companies in the US, a public company that analyzes utility energy consumption from households. They can do a couple of things. One basic thing they do is simply show people how does your consumption look compared to your neighbors. They don't tell you exactly which neighbor, but they just say, compared to your neighbors, you're above average, below average. So this way you can monitor yourself and monitor your consumption. But now what they're doing is even cooler stuff. They're analyzing the power signal, the total power signal going inside of your house. And based on the total power signal going inside your house, not the broken down signal, the aggregate signal, they can tell you your fridge is broken. You need to go maintain your fridge. Or your air conditioning is acting up. Something is wrong with it. You need to call maintenance for the air conditioning. Next one, I'm actually going to skip over this one because we're lack of time, but this is an insurance use case. What's ahead? What's Cloudera focused on? We are focused on the security of this platform. So enhancing the security, enhancing the auditing, the encryption is something that as we enter the government market, as we enter the financial markets, the health markets, is paramount. So we're significantly investing in security and data governance. Ease of use for this platform to be adopted more. It needs to be easier to use. Real-time support is up and coming. And then, sorry for the typo there, but hybrid cloud support is another very key investment area. With that, I will conclude by saying a couple of things. First, we have Strata Hadoop World happening in Singapore on December 1st. Highly recommend that if you would like to see use cases from the industry, this is one of the leading industry conferences, so highly recommend you try and attend. That's not Singapore. Oh. Sorry about that. No, but the slide I have here is not about this. The slide I have here is more about the headline. Data will drive the model world. And I'm using Sydney. I'm using Sydney as an example of the model world. Though Singapore definitely is a very good example of the modern world as well. They're very, very advanced in how they do things. Like Singapore, one of the things I really find interesting over there, they have these meters in the cars, right? All the cars have beacons on them. And depending on which street you're driving in, you'll get charged a different amount. And this way, they can redirect flow at any time by changing the charges. And people just go to the cheaper streets. It's just amazing. But the conclusion really is data will drive the modern world. And all of us, we play a very big role of that in making that happen. So that's the conclusion I wanted to stress on. And with that, I would like to thank you a lot and hopefully take a couple of questions. Thank you for paying attention to me.
Do we have time for a few questions?
Okay, we have one over there. Can we get a mic over here?
Thank you. Thank you for the great talk. I'm from China Mobile. the largest telco company.
Of course.
My question is, so we have lots of data. So it's like every day the incremental data is many terabytes.
Mm-hmm.
So my question is, given your experience, how to control the costs of processing that much data? It's quite easy to make business out of data, but have to play the balance. How, I would just wonder, do you have a rough number, the costs of processing per terabytes or terabytes data?
Yeah, so actually I had a slide that spoke to that. First, the answer to your question is Cloudera. If I go back to a slide I had earlier, I did have an estimate for the cost. So legacy storage systems would cost you on the order of $5,000 per terabyte. Legacy compute systems, meaning databases, will cost you on the order of $30,000 per terabyte. Moving with the Hadoop stack, you're talking about 100 times cheaper. We're talking about $300 per terabyte, and depends how you configure the servers and how many disks you use per server. Now, to even bring down costs further, one step which we're seeing some companies like Facebook do, for example, is moving some of the storage to Blu-ray disks and Blu-ray arrays instead of hard disks. That only works when your data is in a stable mode, meaning for older data, it's not changing anymore. Then you can move it to Blu-ray disks, and that can bring the cost down even further. Thank you for the question. Other questions? Okay, we have a question over here. The mic is coming.
So we heard a little bit about the cloud as being the main answer to big data processing. Have you got any comments on the sort of split between on-premise and cloud that you're seeing at Cloudera, and what that means?
Very, very good question. So the question is about cloud. First, I mean, our name is Cloudera. The reason why our name Cloudera is when we started this company 7 years ago, we actually were going to build a cloud solution. So we want to build a cloud solution where organizations can upload all of their data, do their Hadoop stuff, and then download the results. And we couldn't sell it. Nobody would buy it. The big banks would not buy it. The governments would not buy it. The telecoms would not buy it. The startups wanted to buy it, but they didn't want to pay money for it. They just want to pay for the hardware and not the software. So we had to pivot as a company. And back then, we moved from being a cloud provider to being an enterprise software provider. That said, as you saw me in the conclusion side, I did say that we are now investing in cloud as one of the future directions. Too many slides. Never mind. You saw that it was there. And the reason why is we're seeing a climb now. So right now, 5% of our customers are deploying in the cloud. So about 5% are deploying in the cloud, mainly on Amazon, AWS. But very quickly, we're seeing more and more customers start to ask for that. So we believe there's going to be, this is my belief now, not the Cloudera statement. This is an Amr statement. I believe cloud is inevitable. Cloud will happen because the economics just make sense. It will take time, though. It will take a long time in the same sense that people still have mainframes. I'm surprised today companies still have mainframes. Legacy takes time. So it will take time for everybody to move to the cloud, and the intermediate step will be the hybrid. And that's kind of where Cloudera is investing their energy right now. How do we enable hybrids? Meaning you have a cluster in the cloud, you have a local cluster, and you have transparent mobility of the data and the jobs between the cluster in the cloud and the local cluster. So that's going to be our focus. Thank you for the question.
Thank you.
One more question.
Last question. Last question. Over there. Was that the hand you were referring to? Okay.
Can I? All right. If everybody goes to the cloud, presumably the chip manufacturers don't have to make so many chips and so many drives because there's kind of collective usage of unnecessary duplications and maybe reducing. As a result, the cost actually will increase for the customer, like normal economics, the way it works, supply and demand. So in some sense, is cloud going to be cheaper or expensive, let's say, 20, 30 years from now?
It's a very good question. If a monopoly happens, then it will be more expensive. I don't believe a monopoly will happen. I think there will be at least 3 big players. Amazon will be one of them. I'm not going to name the other 2. And I don't want to upset anybody that might be in the room. The cost economics and the cost advantage of cloud is not the hardware, it's the people. It's the amortizing the cost of the people. That's where the advantages come from. So I don't think the cost of the chips or the cost of the networking is the deciding factor. It's how many people I need to spend versus the cloud provider amortizes over many, many servers compared to me. And that's why I think cloud is inevitable. It's because of that. Thank you for the question. Thank you very much for you paying attention.